Hello friends, and welcome to Webronaq. Here is a question worth thinking about. Who actually controls your internet connection? In June 2026, India gave the world a sharp answer. On June 9th, India's Ministry of Home Affairs withheld the final security clearance Starlink needed to launch commercial services in the country. The reason was striking. Officials were concerned that Starlink terminals had been operating inside Iran during an active conflict, even though Starlink is not licensed there. India's worry was direct. If a foreign company controls a satellite network, can any government truly switch it off in a crisis? That question has turned satellite internet from a tech story into a geopolitical flashpoint. And to understand exactly why it matters, we first need to understand what Starlink actually is and how it works. Alright, so what is Starlink? Starlink is SpaceX's satellite internet service. The key difference from older satellite internet is altitude. Traditional geostationary satellites, the kind that powered HughesNet and Viasat, park themselves at roughly 35,786 kilometers above Earth. They stay fixed over one spot, which sounds convenient, but that distance creates a serious problem we will get to in a moment. Starlink instead uses a low Earth orbit constellation, or LEO. Its satellites orbit at just 340 to 550 kilometers up. As of mid-2026, there are over 10,000 active Starlink satellites circling the planet, making it by far the largest satellite constellation ever assembled. Because each satellite covers a smaller area from that low altitude, you need thousands of them working together to blanket the globe. That dense mesh is what makes Starlink fundamentally different from anything that came before it. Now let me show you exactly how your data actually moves through Starlink, step by step. It starts at your home with a device called Dishy, short for Dishy McFlatface, SpaceX's flat panel user terminal. Dishy is a phased array antenna, meaning it steers a focused radio beam electronically with no moving parts, tracking satellites racing overhead at roughly 27,000 kilometers per hour. Your data beams up roughly 500 kilometers to the nearest Starlink satellite. Here is where it gets interesting. Newer Starlink satellites carry inter-satellite laser links. Instead of bouncing back down to a ground station straight away, your data hops across multiple satellites via laser beams in orbit, traveling at the speed of light in vacuum. Eventually, it descends from a satellite to one of over 200 ground gateway stations, which hands it off to the fiber internet backbone you are already familiar with. Simple in concept, extraordinary in execution. Here is the interesting part. Why does LEO altitude matter so much? Physics. At 35,786 kilometers, the speed of light alone means a round-trip signal takes over 600 milliseconds. That makes video calls choppy and online gaming nearly impossible. Starlink at 340 to 550 kilometers cuts that raw propagation time dramatically. Real-world Starlink latency today is 25 to 50 milliseconds, comparable to a home cable connection. Now add the inter-satellite laser links. Light travels through vacuum about 50% faster than through the glass of an undersea fiber cable. Undersea cables also follow coastlines and take longer physical routes. For certain long intercontinental paths, like a financial trade routed from Chicago to Tokyo, Starlink's laser mesh can actually beat the undersea fiber on pure latency. It will not win on capacity, as we will see, but on speed of delivery across oceans, the physics genuinely favors Starlink. So who is actually using Starlink today? The scale in 2026 is remarkable. Starlink confirmed 12 million active subscribers across more than 160 countries as of June 4th this year. You can see exactly this adoption playing out in industries where reliable connectivity was previously impossible. In aviation, Wizz Air and El Al joined Starlink in June 2026, following Singapore Airlines and American Airlines in May. Passengers on those flights are streaming and browsing over the same satellite constellation we have been discussing. In maritime shipping, Maersk and Hapag-Lloyd have installed Starlink fleet-wide, giving crews communications at sea once unthinkable. And in remote communities from rural Brazil to island nations in the Pacific, Starlink is delivering the first reliable broadband connection those regions have ever had. This is the real-world proof that the technology works. But it also brings us back to India, and a harder question about capacity and control. Now for the honest comparison. Despite everything impressive about Starlink, there is a capacity gap that is genuinely enormous. Total global satellite capacity across all providers is projected at roughly 50 terabits per second in 2026. Total subsea cable capacity is projected at approximately 8,750 terabits per second. That is a gap of about 175 times. A single modern subsea cable like Google's Grasshopper carries up to 350 terabits per second on its own, more than all satellites on Earth combined. This is why undersea fiber cables still carry over 95% of all intercontinental internet traffic. Every time you stream a video, make an overseas call, or use a cloud application hosted in another country, the data almost certainly traveled through a glass fiber on the ocean floor, not through space. Starlink is not a replacement for that infrastructure. It is something different, and in many ways more interesting. So what does the future actually look like? The expert consensus is clear. It is not cables versus Starlink. It is both, working together. Subsea cables handle the raw bulk of global traffic. They are unmatched on capacity and cost per bit. Starlink fills in everything cables cannot reach. Ships at sea, planes in the air, villages with no fiber, and entire regions that lack the infrastructure investment for a cable landing. And the next chapter is already arriving. Starlink's direct-to-cell service, live in the US, UK, and several other countries in 2026, lets a standard smartphone connect directly to a Starlink satellite, with no dish at all, acting like a cell tower in space. The big takeaway from this whole video is this. The internet is a hybrid system, and Starlink is the resilient, universal layer built on top of the fiber backbone the world already relies on. India's freeze on Starlink is a reminder that who controls that layer matters enormously. Thanks for watching Webronaq, and we will see you in the next one.